What's up, guys? Welcome to new Unreal.
Unreal Engine is based on a class hierarchy. As we've seen, the actor class is capable of some very important things. Actors can be placed in a level. We've seen that we can spawn actors at runtime, and that actors can have components. Actors have useful functions like get actor location and get actor forward vector. We've also seen that components are capable of some useful things on their own. Components can be added to actors. Components are based on the actor component class. We've seen that each actor has at least one component. This is the root component. By default, a newly created actor has a scene component for its root. The scene component class is a child of the actor component class. It has no mesh or any visual representation, but it does have a transform, meaning a location, rotation, and scale. It also supports attachment, meaning a scene component can be attached to other scene components. But we saw that we could add new components and attach them to the scene root, or even replace the scene root with a component with more capabilities, such as a static mesh component, which has a mesh that we can see in the level. The static mesh component class itself is a child class of the scene component class. So it inherits the ability to be attached and to have other components attached to it. This is why the static mesh component supports attachment. It is a scene component.
So an actor component, a scene component is an actor component. Static mesh is also an actor component. We need the scene component, static mesh component, actor component. Okay.
So each class has its own properties and functionality that determine what can be done with it. But let's talk about the first sentence spoken in this video. Unreal Engine is based on a class hierarchy. This means that any given class will inherit variables and functionality from its parent classes. The actor class has its own set of properties, and we've seen that if we make a new blueprint class based on the actor class, that our new blueprint class has those properties too. We say that our new blueprint class is a child of the actor class, and that it inherits those properties from the actor class. The actor class has a parent class of its own, the object class. The object class is a parent class to the actor class, and the object class is much more basic than the actor. But those basic capabilities on the object class are inherited by the actor class, because the actor class is a child of the object class. So there exists a hierarchy of classes, and as we go down the hierarchy, classes get more and more capabilities. Let's take a look at the components we've used thus far. We've seen that scene components are fairly basic. They don't have a mesh or any visual representation, but they do support attachment. The static mesh component class is actually a child of the scene component class. The reason we can attach static mesh components to other components and attach other components to static mesh components is because the static mesh component class inherits this functionality from the scene component class. This is a simplification of the hierarchy, as there exist other classes in it as well.
Okay.
For instance, there exists other classes between the scene component and the static mesh component class in this hierarchy.
How deep does this rabbit hole go?
Component. The primitive component is a child class of scene component, and static mesh component is actually a child of primitive component. When we access the onComponentBegin overlap delegate from one of our components, this is a property that exists on the primitive component class. This means that scene components don't have this property, but static mesh components do. The sphere overlap volume that we added to our small sphere actors is a child of the primitive component class as well, and that's why it has an onComponentBegin overlap delegate property, because it inherits this from the primitive component class. If you keep going up the Unreal Engine hierarchy, you'll reach the object class, which is very near to the top. Actor is an indirect descendant of object, and so are these component classes: scene component, primitive component, static mesh component, sphere components. Object is thought of as a common ancestor to all these classes, and therefore we say that an instance of any one of these is an object. So it's important to understand that the capabilities of any given object in the game depend on its class and what classes that class is derived from. Now, we've mentioned before that a pawn is an actor, but an actor is not a pawn. In programming, we often refer to is a versus has a relationships. Think of it this way. A German Shepherd is a dog, and a dog is a mammal, which is a type of animal. The hierarchy goes animal, then mammal, then dog, then German Shepherd. Each time we go down one level in the hierarchy, we get more specific. A mammal is a type of animal, but not all animals are mammals. Some animals are reptiles, which are not mammals, right? Mammals and reptiles are children of the animal class, so they inherit properties that all animals have. Dog is more specific than mammal. A dog is a mammal, but not all mammals are dogs. There are cats, horses, ferrets, etc. So all dogs are mammals, but not all mammals are dogs. We can say that dog is a child of the mammal class. See how this relationship is one way? All mammals, reptiles, dogs, and German shepherds are descendants of the animal class. And we can indeed say that an instance of any of these classes is an animal. So we know in Unreal Engine that all of the classes we've used thus far are descendants of the object class. Object has the ability to store data. It has the ability to have a blueprint made from it. It does not, however, have the ability to be dragged into a level, as we've seen. Now, you have a class derived from object, a child class called actor. We say that an actor is an object because it is derived from that class. So it inherits the qualities of being able to store data and being able to be made into a blueprint from its parent class, object. But the actor also has new, unique capabilities of its own that its parent class does not have, such as the ability to be placed or spawned in a level, among other capabilities. With inheritance, we are speaking of the is-a relationship. An actor is an object, but not all objects are actors necessarily. So this relationship doesn't go both ways, just like with the animal analogy. So we've seen the is-a relationship. This is when a class is the child of another class. We use the terms child class and derived class to mean the same thing. We also say that the child class is based on or derived from the parent class. You'll hear these words base class and parent class used interchangeably. These are all terms for the same concepts. Now let's talk about has-a relationships. We know that our actors can have components. We say that an actor has a component, and there is no inheritance going on with this relationship. When we add a component to an actor class, we are simply making use of a concept called composition, where we extend our actor's capabilities by composing it with additional sub-objects. These are the components. This is the has-a relationship. An actor has components, but the components are not actors, and they're not children of the actor class. So we have two ways to extend the capabilities of any given class. One is through inheritance, by deriving a new class from an existing parent class and inheriting properties from it, and another is through composition, adding subclasses for our class to have. These are the is-a and has-a relationships in programming. More specifically, these are concepts related to object-oriented programming, OOP for short, and they're important to understand because the blueprint system is object-oriented. Now, pawn is derived from actor, so it inherits the ability to be placed in the world or spawned in. But it also comes with more capabilities, such as being able to be possessed. This means we can assign user input, such as mouse clicks and keyboard presses, to control a pawn. This is why we were able to fly around in our game project, because the default pawn is automatically spawned in, and we automatically possess it with some default input behavior. WASD input allows us to move the default pawn. In Unreal Engine games where we plan on using input to move an object directly like this, we make use of the pawn class, and we set up inputs so we can move that pawn, and its movement is tied directly to our input. Those key presses, moving the mouse, and so on. This is different than the movement we've done so far on actors, where our movement was the result of logic in the event graph. This section is all about creating a new custom pawn, so we don't have to just use that boring default pawn. We'll also learn about how to set up inputs so we can press keys and move our mouse to move our own custom pawn class. We'll do this by using Unreal Engine's enhanced input system. So let's get started making our very own blueprint class based on pawn.
Okay. Oh. The Ultimate Interaction Manager is free for professional. Excuse me. You better hurry. This guy's running at like 5 frames a second when he recorded this video.
Welcome back. We're now ready to create our own custom pawn class. Now before we get started, I want to point out something that you may have noticed with your point lights if you have some. Some of them have a little red X. Now if we select one of those point lights in the details panel, you'll see that there's a mobility property, and it can be set to static, stationary, or movable. Now, static means it will never change throughout the game. Stationary means it won't move, but it could change its other properties like intensity. And movable means that it can move while the game is running, and that's the most computationally expensive type of light. Now, because my point lights are just here to light up the walls, they don't need to move, so I can select each one of them and choose static. And that will get rid of those red X's. So I'm just going to quickly do that for all my point lights that I can see. Okay, I think I got them all. Now we're ready to make our pawn class. Now I'd like to get back into my testing level. So I'm going to go to Maps and open testing level, saving my level, so that I can work in here in a nice, well-lit environment. And we're going to make a new blueprint class based on the pawn class. So for this, we're going to go to our blueprints folder and make a new folder called BotPawn. BOTPAWN. let's go into that folder, right-click and make a new blueprint class. And finally, we're going to create a new blueprint based on pawn. We can see in the description, a pawn is an actor that can be possessed and receive input from a controller. That's what we're going to learn about in this section.
Let's do it.
Let's make our new pawn class, and I'm going to call this BP_bot pawn. And we can double click on it to open it up, and we'll see that it looks a lot like a regular actor blueprint. We even have a default scene route, we have an event graph, we have that construction script, which we still haven't gotten into yet. So it's very much like an actor. In fact, a pawn is an actor. Remember inheritance? Now this is
I do.
a pretty empty pawn.
10 minutes
we
ago.
haven't really programmed any functionality for it. We haven't given it any components. It's completely invisible in the game, but we can still use this pawn. In fact, the only reason we get the default pawn when we start playing a game is because we have not assigned our own pawn to be spawned in. But now that we have our BP bot pawn, we can set that in our own game mode, which we're using for our project, right? So we can go into our blueprints folder and go into game and find our BP bad bot game mode. And in the details panel, we can find the default pawn class. And as we can see, it's set to the default pawn engine class. But we can open the dropdown and we can choose our own BP bot pawn. We can compile and save that. And now if we go back and press play, we're going to be possessing our bot pawn. And we can compile and save engine class.
Right there,
but we
default
can
pawn pass.
open the dropdown and we can choose our own BP bot
That's
pawn.
right. There we go. Oh yeah.
We can compile and save
And
that.
now
And now
we've
if
got
we go back and
nothing.
play,
No
we're
controls.
going to
That
be
makes sense.
possessing our
Fully
bot
expected that.
pawn. And frustratingly, you'll find that if we click in the viewport to engage and press WASD, we cannot move. We can't even look around with our mouse. That's because the bot pawn is completely empty. It has no default behavior. That's something the default pawn provided for us. We can hold shift and hit F1 to get our mouse cursor and check out the outliner and see that we do have a BP bot pawn in the world. We no longer have a default pawn. And of course that's because we're using bad bot game mode, which has our pawn designated as the default pawn class to spawn in. So in a way, we've made one step forward and 2 steps back, right? We've learned how to create our own custom pawn and assign it as the default pawn class in our game mode, but our bot pawn is basic and has no movement capabilities, no visual representation, none of that.
Currently.
It's okay because it's a blank slate and we can now program the type of movement that we want to see for our bot pawn. And we can add our own custom visual representation by adding components. So we're going to get started doing all that in the next video when we add some visual representation.
We're going to add...
making our bot pawn a little bit more specialized.
Okay.
Excellent job. I'll see you soon.
Thanks, Steven. Such a nice dude. Okay, before I get into this, or I really start plugging through this tutorial, I better go at the washroom. I need a different texture for the ground here. Just something. Just hate staring at it. Much better. Yeah. I mean, we could scale it down a little bit. Normal map, normal intensity. Oh, yeah, let's go big. There's no change after 1. 1 is pretty much the max when it comes to the normal. That's a little better. It just adds a little something, you know. We got some ground going on. This is important. All right, be right back. What time is it? Here, 8:32. Let's get into this business. Let's go.
Welcome back. So
Thank you.
We now have our nice
Thank you,
shiny
Steven.
bot pawn.
We do,
And
yeah.
we're
It's
actually
super shiny.
possessing that pawn upon playing the game, except there's really nothing to do. We can engage, but we can't really move around or anything like that. In fact, if we detach by using Shift F1 to get our mouse cursor and clicking on detach and moving and looking around, we don't even see that gray sphere anymore that the default pawn had. We don't even have that in our pawn. Our pawn really just has its root component, which is a scene component. And that has no mesh, no visual representation, no collision. It just has its own transform. So in this video, we're going to add some components to our bot pawn to make it more interesting. And we can start with a visual representation. We want to be able to see our pawn. So what we can do is add a new component, and I'm going to start with a static mesh component. So I'm going to choose static mesh, and I'm going to call this bot mesh. And for the static mesh, I'm going to choose SM drone. So we now have this SM drone attached to our scene component, which is the root. And I'm going to take that bot mesh, drag it onto the default scene root to get rid of the scene component and replace it with my bot mesh. Now the mesh is the root component. Now let's go ahead and compile and go back to our testing line.
Oh, look at me.
Let's
Look.
see what happens. Well, seemingly
I'm
nothing because
look at
we
this
can't
guy.
see anything. We can't move around. We can't see our bot. If we press play
Yes, we can.
and right away just detach and we look down, well, we can see that we're looking from just above that pawn. And that's the default location of our point of view. If we want to customize where our point of view is in relation to the root component, we need to add a camera component to our pawn. If we add a camera component, we can then determine where our point of view will be as we possess the pawn. So to our bot mesh, we're going to add a new component, and we're going to search for camera and choose camera. Now this is what the camera component looks like, a blue camera. In fact, we can move it back with the translation gizmo and see the full camera in all its glory.
I like that
Now,
it defaults the
is
camera.
not visible
on
in the game. We can only see it here in the viewport for the pawn blueprint. If we were to drag one of these pawns into the level, like so,
Excuse me.
we can see the camera component there. But if we press play, we cannot see the camera component. It's hidden in the game. But we see that our point of view is changed. It's now here behind the drone mesh. But if we detach, we can zoom out and see that that camera is invisible. Now, why do we see two pawns? Because I dragged one in. That's the one to the left. The one to the right is the one that we are possessing that's automatically spawned in, thanks to the game mode. So I'm going to delete this pawn that I dragged in, and I'm going to go back to my pawn blueprint, and I'm going to move this camera back. And
Oh. Oh, we're going
so.
third person. Oh, okay,
and
okay.
go back and press play, and now we can see the pawn there. We still can't move around, but we can at least see it.
Okay.
So a camera component allows us to specify where our point of view should be when we're possessing a pawn, and we can offset it from the root component, and because it's attached to the root component, it will keep its relative offset. But adding a camera and moving it back like this away from the root component is not actually the right way to add a camera. You see, there exists another type of component designed for the camera to be attached to, and that is a spring arm. So let's click on our root component, which is the bot mesh, click add, and search for spring arm, and get a spring arm component. Notice that it's this red line here, and we have that translation gizmo right here at the root component. The spring arm is also invisible in the game. We won't be seeing that red line during the game. It's just for visualization here. And in fact, if we don't have the spring arm selected, we don't see that red line anymore. But we'd like to attach our camera component to the spring arm component. We know how to do that. All we have to do is click and drag
Way
the
ahead of
camera
you, bro.
onto the spring arm. But our camera had an offset because we moved it away from the mesh. We have to zero that out. So for the location in the details panel, we can hit that curved arrow and zero out that location. And now our camera is attached to the spring arm, which if we select, we can see the red line. And our spring arm allows us to have a camera attached at the end, and the camera will be pointed down the length of that spring arm at the root component. And we can adjust the target arm length. It's here in the details panel. If we adjust it, we'll see that our camera conveniently moves along with the end of the spring arm. And if we go and change our spring arm's rotation by taking that middle value and adjusting it, we can see that our spring arm rotates and our camera rotates with it, and this can be quite convenient. So I could leave that.
Gotcha.
And adjusting it, we can see that and we can adjust the target arm length. That's here in the details panel. If we adjust it, we'll see that our camera conveniently moves along with the end of the spring arm. And if we go and change our spring arm's rotation by taking that middle value and adjusting it, we can see that our spring arm rotates and our camera rotates with it, and this can be quite convenient. So I can leave that at negative 20 degrees, and we have an angle here. And now if we go and play test, we are looking at the pawn from this angle.
Amazing.
Distance. The spring arm is a really nice type of component because our camera, by default, can collide with things like walls. And if we back up against a wall and the camera hits it, it'll shrink down along that spring arm. The spring arm will shorten to accommodate, and we'll see how that works soon once we start implementing movement.
Smart.
So now our bot pawn is looking a lot less empty, right? We have a visual representation, we have a camera, so we're determining where the point of view.
Input.
Back.
That's
So
not
bot
that.
pawn, and it has a bot mesh, it has a spring arm and a camera component, but we still can't move it. And to move it, we need input. We need to be able to press buttons, move the mouse, and have that result in moving our pawn. And in order to make that happen, we have to make use of Unreal Engine's Enhanced Input system. Enhanced Input involves a number of parts that come together to allow us to handle input for the pawns that we possess. So we need to make a couple of new classes, and we're going to keep those new classes in their own input folder in Blueprints. So I'm going to right click, choose new folder, and call this folder input. We'll go into input, and we'll make a new type of asset here related to input. Let's right click and find the input category, and here in input we're going to choose input action. Now before I click on it, take a look at the pop-up and read it. The first line says an input action is a logical representation of something the user can do, such as jump or crouch. These are what your gameplay code binds to in order to listen for input state changes. We're going to see what that means very soon. Let's go ahead and click on input action, and we prefix our input actions typically with IA, which stands for input action. Now I'm going to call this IA fire, as in firing a weapon. This is going to be a very simple type of input action. I'd like this to represent the action of firing a rifle. I'm going to double click on it and open up the input action asset. Here's what it looks like. It's quite simple. And really the most important thing to look at here is the value type, which has a drop-down. It says digital bool, and we know that bool or Boolean data types have only two possible states, true or false. An input action that has a value type digital bool is the most basic type of input action. It's usually for a single button press. The input action contains the information regarding whether or not the button is currently pressed. But that's all the information it can handle. Notice there are other types: axis 1D float, axis 2D vector 2D, and axis 3D vector. We'll learn about more of these soon, but let's just keep this at digital bool. And we now have an input action. Great. But what do we do with it? Well, we have to associate it with some kind of input, whether it's a keyboard key or a console controller button, for example. We do that with a new type of asset. We're going to go back to our input folder and make that new type of asset now by right-clicking, going to Input, and selecting Input Mapping Context. Let's choose that and call this IMC for Input Mapping Context bot. This will be our IMC bot input mapping context. The mapping context is what we use to link an input action to a given type of input, a certain button or key, etc. Let's open that IMC bot, which again, just like input actions, it's kind of basic, but we need to take a look at mappings. Mappings here is an array. We can add elements to it with the plus icon, and as soon as we do that, we have a drop-down we can expand, and we have a single mapping here which has its own triangle we can expand and its own drop-down where we can select an input action. Now there only exists one input action in our entire project. That's IA Fire. That's the only choice we have, so we can select that, and our drop-down now says IA Fire. And if we expand its triangle, here is where we can choose which key is going to be associated with this input action. Which key do we want to press to fire our weapons, right? Now, we can choose the key or button or any other type of input from the drop-down. If we expand it, we see lots of different categories. If I want the left mouse button, I can find mouse, expand it, and there are different types of mouse input. Most notably is the left mouse button. We can choose that there. And now IA Fire has the left mouse button associated with it. Now, we can remove that association by clicking the trash can, which says Remove Mapping. That's going to remove the entire mapping. So if you did that, go ahead and click plus to add that IA Fire back. Now, rather than going and searching for the key or the mouse button, there's a shortcut. We can click on this icon here, select the key value. If we click on it once, it becomes yellow, and we can then press any key on the keyboard, such as the F key, and now F is associated with IA Fire. And we can do the same thing for mouse buttons. I can click on it and click the left mouse button to associate the left mouse button to IA Fire. Now, the cool thing about input mapping contexts is we can associate more than one button to a single input action. We do that by pressing the plus icon next to that mapping. Not the plus icon next to mappings, but the plus icon next to the individual mapping associated with this input action. If I click on plus, I now have an additional input associated with IA Fire, and I can choose what that key can be. I can click on the keyboard and press F, which is a shorthand for finding the F key under keyboard here and searching for it and selecting it. So now left mouse button and the F key are both associated with IA Fire. All right. So the input mapping context is where we tie inputs to the input actions. The last piece of the puzzle is to associate the input mapping context with our pawn. To do that, we go back to the pawn class and open our event graph. Now we can do this in Begin Play, and the way to do it is as follows. And don't worry if you don't commit this to rote memory, because you can always come back to this video and remind yourself how it's done. But the way to do it is as follows. First, we need to access our controller. You see, when we possess a pawn, we do so through a controller. Every pawn that is possessed is actually possessed by a controller. To access the controller, we right-click and search for Get Controller. And we choose Get Controller. This is a function on the pawn class. Actors don't have it because they don't get possessed by controllers. Pawns do. And if we hover over the return type, its type is controller object reference. Now, controller is a base class. It's a parent class, which is very basic. But our pawn has a more specialized child class of controller called player controller. And we need the player controller. We need our controller in the form of the player controller data type. And remember, this is what casting is for. So we can drag off of that controller data type and search for cast to player controller and choose that. And the return type here says player controller object reference. This is a child class of the controller. A player controller is a controller, right? We have that is a relationship going on. So in begin play, we're going to access the controller that's possessing this particular pawn, cast it to player controller. And why did we need it in the form of a player controller? Well, that's because we need to access something called the Enhanced Input Local Player Subsystem. Notice under Player Controller, under Local Player Subsystems, we have this function to get Enhanced Input Local Player Subsystem. Now, a subsystem is an object that exists in our game. There's only one of them, and we can access it through this get function that belongs to the player controller. If we click on this Get Enhanced Input Local Player Subsystem, we have this one big fat node that returns an Enhanced Input Local Player Subsystem object reference. And this is how we associate input mapping contexts. We drag off of it and we search for Add Mapping Context. If we select it, we now have a new function call to Add Mapping Context. This is where we can choose the mapping context we want to add. We have to connect this to our cast node. Make sure you don't use cast failed. We need the top execution pin. And we can choose the mapping context from the dropdown. Our project only has IMC bot, so I'm going to choose that. Now there's a priority because we can add multiple mapping contexts at varying priorities, and the mapping context with the highest priority takes precedence. Let's say I had two of these with different input actions associated with the left mouse button. If we had both mapping contexts added at the same time, the one with the highest priority is the one that's going to trigger that left mouse button input action. But anyway, now we've added our input mapping context here and associated it with this given controller, and this opens some interesting doors for us. We now have the ability to make use of our IA-Fire input action, which exists in IMC bot, our input mapping context, which we've used to associate the left mouse button and the F key with it. So I'm going to go ahead and remove these two nodes, tick and actor begin overlap. We don't need those. And this set of nodes here, where we're adding the input mapping context, this can get its own comment. You could even collapse it into a function if you'd like to do that. But I'm just going to press C to give it a comment and say add bot input mapping context. And I'll go ahead and give it its own color. We'll give it red. Something I like to do is double click the wire here to give it a reroute node. That way, if I need to move the comment around, it's going to anchor to that little reroute node there. So now that we've added the input mapping context, we can choose what happens whenever we trigger the IA-Fire input action. In other words, the keys and buttons we've associated with IA-Fire in the IMC bot input mapping context are going to trigger some kind of functionality. We can determine what that is by going to our bot pawn here, right-clicking in the event graph and searching for IA fire. Now we have two options here. Something that has a little arrow indicating that it's an event. If we click on that, we have this event we can implement, and we can expand its dropdown, and we see that it has a number of execution pins and data values that it provides. So we can choose what happens in response to triggering IA fire with the F key or the left mouse button. Now, if we right-click and search for IA fire and choose the other option under Enhanced Action Values, this looks like a Blueprint Pure function, right? And that's what it is. Because our IA fire has its value type set to digital bool, there's a Blueprint Pure function that returns the Boolean value that'll be true if those inputs are being pressed currently. If they're not being pressed, the value will be false. So that's a convenient way to check to see if the F key or the left mouse button are currently being held down. But this IA fire event can do that too. You see, we have a number of things that will trigger.
Okay, let's just try this. You are firing. Oh. Actually, let's do it like this. No, that's just gonna print it over and over. Oh, I see. But you have to be pushing it, so it does work. Just getting it every tick, excessively. Okay.
Based on the status of that input. The first one, triggered, will be executed every frame as long as the input is held down. We can prove that with a print string node. We can say triggered. We also have started, which is only executed once when that input is pressed. We can add a print string node for that one, and we can say started, and I'm going to change its color to a more reddish color here. Now, ongoing and canceled have to do with a press and hold threshold, which we have not implemented for this input. That's a little bit more advanced, so we won't touch on those. And completed is going to be triggered as soon as that input is released. We can add another print string with its color set to red, connected to completed, and I'll put completed here for the string. And now we have some responses for when our input action is fired off.
Triggered will be light blue. Started will be a slightly darker blue. And then completed will be very dark blue. Started, triggered, completed. I see it. This is magic.
I'd like to change the duration for these from 2 to, let's say, 60. And that way we can analyze these messages that get printed to the screen. So I'm going to change the duration for all three of these print string nodes to 60.
Yeah, I'm not doing that. That's a little unnecessary.
And now we can play test, and as soon as I press play and click in the viewport, notice that I have some messages here. Now, the newest messages appear on top, remember? So the started message was first printed to the screen, and then we had triggered printed every frame until I released my mouse button, at which point completed was printed to the screen. So we have the ability to respond to when a button is initially pressed, and the ability to respond to when that button is released, as well as a way to fire off logic continuously every frame while that button is held down. So this is quite versatile. If we only want to perform a single one-off action as soon as the button is pressed, we have started. If we want to trigger something every frame as long as the button is being held down, we have triggered. And if we want something to happen as soon as we've released that input, that's what completed is good for. Now, we don't have to just rely on print string nodes. I'm going to delete those three so we don't have anything hooked up here, and go back and press play and click in the viewport to engage. And I'm going to use a special console command. We can enter console commands by hitting the tilde key on our keyboard. Now this little black text bar pops up, and I can enter the console command show debug, one word, enhanced input, also one word, and if I hit enter, we now see some information at the top left. We see that we're showing debug for BP bot pawn. We can press page up and page down to cycle between, and I'm going to use a special console command. We can enter console commands by hitting the tilde key on our keyboard. Now this little black text bar pops up, and I can enter the console command show debug, one word, enhanced input, also one word, and if I hit enter, we now see some information at the top left. We see that we're showing debug for BP bot pawn. We can press page up and page down to cycle between targets, so if we had multiple pawns possessed by controllers using enhanced input, the page up and page down keys would cycle to showing information about those objects. Now, we have a number of bits of information here. It even shows my computer name. We have the location and rotation of our pawn. We also see that our pawn is possessed by player controller. That's the class of the player controller possessing the pawn. That's why the cast from controller to player controller was successful. And we also see enhanced input values. It shows that we're using the IMC bot input mapping context, and that there's a single action, IA fire, and it has left mouse button and the F key associated with it. Now I'm going to press and hold the left mouse button, and look at this. It shows that it's triggered, and it's also keeping track of how long it's being triggered. I've now held it for 8 seconds and counting, and if I release, now it goes back to 0. So it keeps track of how long we've held an input. That's just built into the enhanced input system. Input actions keep track of how long they're pressed, and that allows us to avoid having to keep track of that using blueprint nodes and such. Now I can press the F key, and we can see that IA fire is being triggered, and we're keeping that running count. And I can release, and it stops. And notice as I'm holding down the inputs, we see true next to left mouse button in this case, or if I hold F, we see true next to F. Because this IA fire has the value type bool, and we get that true as the value in that input action as the button is pressed down. So show debug enhanced input is a nice console command that you can enter while the game is running. Now, something that trips up a lot of students is they'll try to hit tilde when the game is not running, and they'll get this console text box down here. And not all console commands work down here.
Okay, let's see. Let's just spawn BP, not sphere spawner. There we go. It's not playing a sound effect though, which I guess that's on my bot itself and not in the mesh, or not in the BP for that, which is too bad, because really it should be on the. That's just in the bot. Oh, I see. We're just doing collision here.
There are some that only work while you're engaged in the viewport. In other words, a Pi session has to be running and you have to click and engage in the viewport first before you press tilde and you get this other in-game console command line. So not all console commands work. In this one down here, sometimes you have to be engaged in the viewport before you press tilde for them to work. But if you press play and start a Pi session and you enter that command down here, show debug enhanced input, it will work because the game is running. So in this case, we can use either one. But if you stop the Pi session and enter show debug enhanced input, nothing happens because the game isn't running. And one other handy tip is if you bring up the command line and press the up key on your keyboard, it's going to automatically populate with the last command that you ran, so that can save you some typing. All right, so I know this was a lot to take in. This is a kind of big lecture, but you can always refer back to this lecture. You can take notes on this lecture, because this is the same process that you'll go through every time you set up a new pawn with input. You always need to create input actions, create an input mapping context to associate those input actions with inputs, and you always have to add an input mapping context to your pawn, and you do that by getting the controller, which returns a controller object reference, casting it to the player controller, which returns a player controller object reference, getting the enhanced input local player subsystem from the player controller, and calling add mapping context, specifying the context and the priority. Now, if you've done some experimenting on your own, you might have found that you can right-click and type get player controller. Now, this is different to associate those input actions up the command line and press the up key on your keyboard. It's going to automatically populate with the last command that you ran, so that can save you some typing. All right, so I know this was a lot to take in. This is a kind of big lecture, but you can always refer back to this lecture. You can take notes on this lecture, because this is the same process that you'll go through.
So right now, my bot mesh is not facing my actual player controller star. How do I see what the difference is so I can orientate it to that star? Because I can look at my player start here and I can see that it is off. Oh. Now it should be fine. Ah. Let's go back to the spring arm. Let's go back to the viewport. We just want to do a little rotation. Yes, much better. Much better. I did it.
Every time you set up a new pawn with input, you always need to create input actions, create an input mapping context to associate your input actions with inputs, and you always have to add an input mapping context to your pawn, and you do that by getting the controller, which returns a controller object reference, casting it to the player controller, which returns a player controller object reference, getting the enhanced input local player subsystem from the player controller, and calling add mapping context, specifying the context and the priority. Now, if you've done some experimenting on your own, you might have found that you can right-click and type get player controller. Now, this is different than get controller. This is a function that returns a player controller in the world with a given player index, as each player in a game has a player index associated with it. And you may find that this will work in a game with one player with a single player index, but if there are multiple players, each one will have a different player index. So it's generally not a good idea to use get player controller, as you don't know if the player index is correct. And you'll notice if we hover over this, we see target is gameplay statics. This is a function library with functions that you can just call from anywhere. Whereas if you hover over get controller, we see the target is pawn, which means this is a function belonging specifically to the pawn class, and it gets the actual controller that's currently possessing the pawn that's calling the function. So this gets us the true controller possessing the pawn. So while you could use a single node to get the player controller and avoid the cast, this is linked to the player index, whereas get controller is linked to the pawn that's calling it, and this is guaranteed to give you the correct.
Let's go in here. Flip flop. Let's do this right there. This is function A. And then we're gonna duplicate all that. Actually, we don't. Oh yeah, we do. We do need to duplicate all that right there. Let's do plus 10 and negative 30. Okay. We're just gonna go forward just a little bit, just a little bit. Just. Oh no, that's fine. 10. 10. Oh, not enough. No. In an ideal world, I would just make one function, like one variable, and then what if you can do like a plus or minus flip-flop? Okay. How far do we have to go here? That doesn't make any sense. Let's do this. Let's do a little spring arm rotation. Why does that one spawn just a little more? Oh. Right. That's my camera forward direction, but my mesh is not lined up with it. Well, he's going to help us out.
So that's just an aside, but that's why we use get controller and cast it to a player controller instead of calling get player controller. All right. So as I mentioned, there's a lot here to set up just to get the left mouse button to trigger some kind of action that we want. But the good news is now that we've set up our input mapping context, it's going to be very easy to set up additional inputs and add them to that mapping context.
Let's do it. I'm already done. I'm ahead of you, bro.
So we now have our bot pawn. We're possessing it. We can see from the point of view of the camera component, and we even have an input mapping context added, and we can respond to the activation of the input action IA fire. Now what I'd like to happen is for our bot pawn to fire a blaster beam whenever we press on one of the inputs that we've linked up to this input action. In my case, I've linked up the left mouse button and the F key to IA fire. So whenever I press one of these, I'd like to fire a blaster beam. So that's the goal. And in addition to that,
pew 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 pew.
I'd like to alternate between left and right rifles, just like our bot actor does. So this is going to be a challenge for you. For this challenge, I'd like you to set up firing the rifle in response to the input action IA fire. every time we click that left mouse button or press the F key, I'd like to see one of the rifles fire a blaster beam. And preferably, I'd like those blaster beams to alternate between left and right rifles. Now, see if you can do this without going into the BP bot actor blueprint to see how we fired blaster beams before. But if you get stuck, take a look at that class.
I did it.
Find yourself how you can spawn
Now,
blaster beams.
I'm pretty
Pause the
sure.
video.
Pretty sure that I can add socket. Oh no. Where is the sockets? I don't know. I'm on the mesh. I don't remember how to add sockets, and this is... Add a socket. Oh no, I want to search the components. No, okay.
And tackle this challenge now. Okay, so I have several execution pins to think about. I know that triggered will be executed every frame as long as my input is held down, whereas started will fire off once per button press. So that's what I want. And much like we did in BP bot, I'd like a handy function that can do that. So I'm going to add a new function by clicking add, going to function, and I'm going to call this fire rifle. Now this could be a name, but I'd like fire rifle to handle the names for the socket. I'm just going to add a Boolean variable here called isLeftRifle. Fire rifle. Now this could be a name, but I'd like fire rifle to handle the names for the socket. I'm just going to add a Boolean variable here called isLeftRifle. It'll be true if we're firing the left rifle, and false means we'll be firing the right rifle. And here in fire rifle, we're going to get a socket location. So I'm going to call get socket location and choose the one with bot mesh. That way we'll be calling it on the bot mesh itself. And if I'd like to go back to my bot to see what the socket names are, I can click on my bot mesh, find that static mesh SM drone, and browse to it, and open that up and take a look at my sockets. They're called rifle_L and rifle_R.
That's right, that's on the mesh.
So here's what I'm going to do. Here inside fire rifle, I'm going to place a branch.
Oh yeah, right. For sure.
I'm going to check if is left rifle is true, and if it is, I'm going to create a brand new local variable, a variable local to this function. It doesn't exist outside the function. It gets created when the function is called. So I can go to variables, create a new one, call it socket name, change its type to name, and set socket name to rifle under. Underscore L, and I'm going to do.
Uh-oh.
Duplicate this setter. And set it to rifle underscore R. In this one, that'll be in the false case. So if is left rifle is true, this local socket name variable will be set to rifle L, otherwise it's set to rifle R. Next, what I can do is I can spawn an actor. I'm going to call spawn actor from class, and for the class, I'm going to choose BP blaster beam. And both of these set nodes are going to hook in to this spawn actor node. And I can right-click spawn transform, split the struct pin, and use the result of get socket location here. I can also get socket rotation. So get socket rotation, I can do.
Gotcha. Okay. Okay. I'm a little confused. So this fire function here, I don't understand how it knows it's the left rifle right here. It's getting the socket name here. Doesn't matter.
That and hook that in for the rotation. And if I didn't want two nodes, I can have a more compact version of this by calling get socket transform. And I can right click the return value, split the struct pin, and simply by calling get socket transform. And I can right click the return value, split the struct pin, and simply.
Ah, that makes more sense. Get socket transform, bot mesh.
Simply plug in location and rotation, and in fact, if I'm going to do that, I can just recombine the struct pin on both of these and simply plug in the transform itself. Now I need to specify a socket name. I'm going to use the socket name local variable here. going to add a Boolean variable here called isLeftRifle. It'll be true if we're firing the left rifle, and false means we'll be firing the right rifle. And here in fire rifle...
Right, so it's not checking it. It's just giving me an output. I'm defining it here, I believe. It's firing the left rifle. Rifle left. It's, yeah, so, right. I'm just getting this information out here. That's not checking anything. I get it. We're spawning this class. So the function is to run this.
We're going to get a socket location. So it'll be true if we're firing the left rifle, and false means we'll be firing the right rifle. And here in fire rifle, we're going to get label here by clicking add, going to function, and I'm going to call this fire rifle. Now this could be a name, but I'd like fire rifle to handle the names for the socket. I'm just going to add a Boolean variable here called isLeftRifle. It'll be true if we're firing the left rifle, and false means we'll be firing the right rifle. And here in fire rifle, we're going to get a socket location. So I'm going to call get socket location and choose the one with bot mesh. That way we'll be calling it on the bot mesh itself. And if I'd like to go back to my bot to see what the socket names are, I can click on my bot mesh, find that static mesh SM drone, and browse to it and open that up and take a look at my sockets. They're called rifle_L and rifle_R. So here's what I'm going to do. Here inside fire rifle, I'm going to place a branch. And I'm going to check if isLeftRifle is true. And if it is, I'm going to create a brand new local variable. A variable local to this function. It doesn't exist outside the function. It gets created when the function is called. So I can go to variables, create a new one, call it socket name, change its type to name, and set socket name to rifle_L. And I'm going to duplicate this setter and set it to rifle_R. In this one, that'll be in the false case. So if isLeftRifle is true, this local socket name variable will be set to rifle_L, otherwise it's set to rifle_R. Next, what I can do is I can spawn a return value within a function, both of these, and simply plug in the transform itself. Now I need to specify a socket name. I'm going to use the socket name local variable here. So local variables are nice because they don't exist on the actor itself. They exist locally within a function. They're created and destroyed within the scope of that function, which is nice. So now I can call fire rifle, passing in a Boolean, true or false. True means we'll fire the left rifle. False means we'll fire the right rifle. So we can test this out. I'm going to go back to the event graph and call this function fire rifle on started. And I'm going to pass in true and see if we can fire the left rifle. Let's play test. I'm going to left click, and there it goes. We fired the left rifle. Now, we want alternating behavior, right? And that's what the flip-flop is good for. So I can right-click, type flip-flop.
Did this earlier.
Hook that up to started, and hook A up to fire rifle. And I can duplicate fire rifle, hook it up to B. And I can uncheck is left rifle here.
Oh, obviously you don't need that one. Yes. Is left rifle, fire. That's right. Okay, so defining the variable here is left rifle, and then I'm flip-flopping to not being the left rifle. We go into the fire rifle. Let me see. Because we're bringing the variable in. If it's true, we're going to set the socket name to fire left. We're going to spawn there. We're going to get the socket transform. I'm going to take that socket name, which is that, which matches up. Okay, I get it now. Come on in. We're going to fire if the socket name is left. If it's true, if not, we're going to say that we're going to fire the right, which I understand. Get socket transform. It's pulling straight off that socket using those two variables, right, left, right, left, right, left, on the bot mesh. And we're just taking this variable outside here, is left rifle. And that's what we're going to flip-flop it. Is left rifle, boom, boom, boom. Take that variable inside. I get it.
And if we play test this, we expect to see alternating rifles. Let's check it out. Left, right, left, right. Perfect.
I get it.
Okay. Now, you may be thinking, well, flip-flop returns a Boolean that says is A. This should be true every other time and false every other time, shouldn't it? So theoretically, we should be able to just get rid of one of these function calls and hook both A and B up to fire rifle and simply pass is A in for is left rifle. Would this work? Let's check it out.
Oh, that's cool. Is A, is B. Pretty much the same thing, but that's cool. Oh, bring me back out. Cool.
Let's press play and fire. And look at that. We're alternating.
So I guess the easiest way for me to do this is first spawn this. Where do I want it to spawn from? I want it to spawn on the socket. I'm just going to call it socket name. Now I'm going to set the not socket name to be left or right. And it's going to go in between based on this left rifle condition. And then outside here in the main thing is where we're going to set the rifle condition. Yeah. Interesting. Yeah, I feel like working backwards is how I work best.
So it does work. That allows us to have one less.
That's cool.
And things look a lot cleaner. Okay, so that was the challenge, and if we like,
I did it in a wrong way, but it
more
kind
things to
of
this
worked.
function, such as spawning particles and sounds as well. Now for this, I'm just going to go straight over to my drone folder and open BP bot and open spawn blaster beam and steal a couple of nodes here. We're going to steal spawn system at location, and play sound at location. I'm just going to copy these nodes and come. Back to BP bot pawn here in Fire Rifle and paste them in. Now the interesting thing is that in BP bot we had socket name, right, which was a input parameter to this function. This is kind of like a local variable. It's local within the scope of the function. It doesn't exist outside of it. When I created a local variable in Fire Rifle, I created a variable that's local to the function like that, but it's not an input parameter. That's the only difference. But because the variable socket name exists within this function, I can paste that node in and it just links up and it uses socket name. Pretty convenient. So I can hook these up and we can play test this. All right, excellent. And we can fire our rifle. This is looking great. Now you may be tempted to hook this up to triggered as well and see what happens if we simply hold the mouse button down. Well, that's going to fire every frame, which is way too fast. Watch. Yeah, way too fast. However, if you did want to be able to hold that input down, there's a special thing that exists in the enhanced input system. If we go to IMC bot and take a look at our input mapping context here, we'll see that each of these input actions has triggers and modifiers. These are arrays. They're empty, but these allow us to change behavior for inputs. Modifiers affect the value of our input action after they've been triggered. Our value in the case of IA fire is a Boolean value. We don't want to change that. Triggers, however, allow us to affect the way an input action can be activated or triggered. Let's add a new trigger by clicking plus, and from the drop-down we can choose from any number of these built-in triggers, and the one I'm interested in is called Pulse. This allows us to throttle that triggered execution pin. Let's choose Pulse and expand this index, and we have some options. This is going to make our trigger activate every so often according to the interval. The interval is set to 1, and this is in seconds, but I'm going to set it to 0.25, and I'm going to leave trigger on start checked. Now if we go back to bot pawn, I'm going to disconnect the started pin and leave this on triggered and see what happens if I hold my mouse button down. Now we're triggering every 0.25 seconds, and I can lower that to 0.1 if I want faster behavior. So the pulse trigger is going to throttle that. However, I only added it to left mouse button, and I press the F key. Well, that's way too fast. I have the option to add this same trigger and configure the same settings for it to the F input action. But if I want them all affected by this pulse trigger, well, I can add them directly to the IA fire input action. So we're going to do that. I'm going to remove the trigger from here in the input mapping context with the trash can icon, and I'm going to go into IA fire, which has its own triggers array. I'm going to add one. I'm going to choose pulse, and I'm going to expand it and change the IA fire input action. So we're going to do that. I'm going to remove the trigger from here in the input mapping context.
I see. I gotta go right here.
I'm going to go into IA fire, which has its own triggers array. I'm going to add one. I'm going to choose pulse, and I'm going to expand it and change the interval to 0.1, like so. And now if I play test, I can try holding down the mouse button, and I can try holding down the F key. And that too works. Excellent. 0.1 seconds might be too fast.
Okay.
Welcome back. Now things are getting pretty exciting because we can fire our rifle, or I should say rifles, plural, and that's pretty amazing, but we still can't move around. I'd like WASD movement to move around in space. We'll get to that, but what I'd like even more is to be able to move my mouse and look around and rotate our drone. So to do that, we need a new type of input action. We made one input action for IA fire, which has the value type digital bool. We've seen that it's true when the button is pressed and false when it's not, but we need something different from mouse input. When I move my mouse left and right, I want to rotate left and right. And likewise, when I move my mouse up and down, I want to rotate up and down. In other words, we have two different values. A value for moving left and right, we call that the mouse x-axis, and one for moving our mouse up and down, we call that the mouse y-axis. So we're going to make a new input action for that. And because we're now going to have more than one, let's make a folder here in input, new folder, called input actions, and move IA fire in there. Make sure when you drag it onto the folder, you click move here and not copy here. You don't want to copy that. And here in input actions, we're going to go to input and create a new input action called IA look. This will be for looking around with our mouse. Let's open that up. And this one's value type is not going to be digital bool. It's going to be
Axis 3.
2D,
Oh.
we have two axes when it comes to mouse movement. X-axis, moving
Yes.
left and right,
That makes
and
total
the
sense.
y-axis moving up and down. So let's choose that. And let's open IMC bot and click plus next to mappings to add a second mapping. Open the drop down and choose IA look and expand that. Now I'm going to open the drop down, go to mouse, and choose mouse XY 2D axis. Now this is going to trigger every frame as long as our mouse is moving. We can expand that. We can see that we can add triggers and modifiers if we want. But for now, we're just going to leave it as is. And we need to respond to IA look by going into BP bot pawn, into event graph, right-clicking and searching for IA look. And we want that event, so let's get that. Now, this one has an action value that's different than the action value for IA fire. Remember, IA fire has the digital bool type, right? So it returns a boolean when it's triggered, but IA look is vector 2D. Now, a vector 2D is very similar to a vector, except instead of XYZ, it only has X and Y. It does not have Z because it's not a three-dimensional vector, it's only a 2D vector. Now, it's a structure, and just like hit results, which are structures, we can break it. We can always drag off of a structure type and search for break and break this particular type of structure. If we choose break vector 2D, we can access its contents, which just happen to be X and Y values. Now here's how it works. As we're moving our mouse left and right, we'll have a value for X, which is indicative of how quickly we're moving the mouse. Same for the Y. So what we want to do is move something when our mouse moves. Now it's tempting to say, well, we should get our spring arm and we should set its rotation or add to its rotation. And yes, intuitively that would make sense, but what I'd like to move instead is my controller.
Here's the mesh.
Remember, our pawn has access to the controller.
Well, yeah.
We accessed it up here in begin play with get controller. I'd like to rotate my controller whenever I move my mouse. Why? Because the controller is a great thing for other components to follow. If I rotate my controller, I can follow that with my spring arm, for example. So a lot of newcomers are confused by this decision to rotate the controller instead of some tangible component on the pawn itself. Why not rotate the mesh? Why not rotate the spring arm? Why rotate this invisible thing called the controller? We can't see the controller, and the controller doesn't have a mesh or anything. But the controller does have a rotation, and our components are designed to be able to follow the controller when it rotates. So it makes sense for something called a controller to control how our pawn rotates, and that's the direction we're going to go. So if we right click, we can search for a function, add controller, and we have, look at this, 3 functions: add controller pitch input, add controller roll input, and add controller yaw input. Now we know what yaw, pitch, and roll are. Let's start with yaw. Add controller yaw input. This takes in a value, and this is the amount to add to our controller's yaw. And we've already seen that moving our mouse left and right is the x-axis of our action value. So as our IA look input action is triggered, every frame we're going to get a value for x based on how quickly we're moving left and right. So if we hook this up to triggered, and we hook up the x in for the value, we'll be moving our controller. We'll be adding to its yaw. And there are ways to follow the controller's rotation. For one, we can choose our spring arm in the details panel. Can search for control, and look at this. There's a variable called use pawn control rotation. This is what allows our spring arm to follow it. Let's check that and go back and press play.
Ha! I saw that earlier. Right, the use pawn control rotation. I saw that. Okay.
Play, engage in our viewport, and let's move our mouse left and right. And we can see that we're moving our spring arm, and our camera, being attached to that spring arm, is moving along with it. How about that?
How about that?
Now our mesh is not moving, so I can rotate around to the front, and I can see it. Let's say I wanted to see those cannons fire straight on. Pretty cool. Now that's only for the yaw, right? We saw that we can only move our mouse left and right. If we move up and down, nothing happens. Well, that's where that second axis comes in, the y-axis from our action value. We're going to use that for our pitch. So let's search for add controller pitch input. Let's pick that up and pass in the y-axis value from that broken vector. And let's see what happens now. Now we can move our mouse up and down. Now, if it feels unnatural to you, like you should be moving the mouse up and looking up instead of looking down, you may want to reverse the value for that y. You may want to reverse the sign. In other words, we could take y and multiply it by -1 and pass that in. But that's not the way to do it. The way to do it is by going to IMC bot to our IALook input action and add a modifier to it. Remember, modifiers modify the input action value after being triggered. So let's click plus to add a modifier, and we have a number of built-in modifiers. The one we're interested in is negate. And if we expand negate, we can negate or reverse the sign of any of the axes of our input action. Now, it doesn't have a Z because it's only a 2D input action, and we don't want to reverse the value of the X, so we can uncheck that. We just want to negate the Y. So if we have this input action negated on the Y-axis, then we can go back and move our mouse. And now when we move our mouse up, we look up instead of down because we've negated that input action value for the Y-axis. And now we're able to move our mouse and look around our pawn. Pretty nifty. Welcome back.
Thank you for having me. I'm excited to be here. $10:04, Kira. Hey, what time do we want to go to the store? Okay. Do I want to keep going on this? I feel like I should go do some running around, get some shit done in the real world, give myself a bit of a breather, and then come back to this. My mind will be a little bit less cluttered with things I gotta do. So I will be back a little bit later on. I don't think anyone's here, but that's fine. I'll be back.